Next, let's talk about how the Gibbs free energy depends on both pressure and also temperature. Okay? The ultimate criterion para masabi natin na spontaneous or favorable yung ating process is that the entropy of the universe, ibig sabihin total entropy, should be greater than or equal to zero. Ang problema again is that the entropy of the universe is the sum of the entropies of the system and the surroundings, and it's quite difficult to account for the entropy of the surrounding. But the good news is there's another way to determine whether a process is spontaneous or not, and that is using the free energy functions. So another way para masabi natin yon is that delta G should be greater than or equal to 0. I'm sorry, it should be less than or equal to 0. Okay? Or kung Helmholtz function naman, so the Helmholtz change should also be less than or equal to 0. So all this will describe a spontaneous process. And usually we go with the Gibbs free energy, especially for processes that are happening under constant pressure. Now, let's try to find mathematical expressions that will show how the Gibbs free energy depends on both pressure and temperature when the other is constant. So mag-uumpisa tayo dun sa ating definition or yung ating formula for change in Gibbs free energy. So that's dG, okay, we have shown this before, equals minus S dt plus V dP. Okay? And this shows that the Gibbs free energy is a natural function of temperature and pressure. So temperature and pressure are natural variables for the Gibbs free energy. And from here, we can take the total derivative of the Gibbs free energy function. We have shown this before, so this is just a refresher. So that's partial derivative of G with respect to T at constant P dt plus partial derivative of G with respect to P at constant T dP. And you can see now the correspondence, no, nung dalawang term na ito with S and V. So let's write that down. Ibig sabihin, lumalabas na the change in free energy Gibbs with respect to T at constant P is equal to minus S, and the change of in free energy with respect to pressure at constant temperature is equal to the volume. Okay. So ang gusto nating mangyari ngayon is to determine the pressure dependence of G with when T is constant, or how free energy depends on pressure when T is constant. So kung yan yung gusto nating malaman, then we should be able to use this equation here. Okay? So kukunin natin yan, and what will happen is that we can simplify that, or we can somehow rearrange. So magiging dG, change in Gibbs free energy, is equal to V dP. Okay, so this is another way of expressing that. Basta tandaan nyo lang na this is at constant temperature. Okay, so now this equation will show how Gibbs free energy depends on pressure. Well, pwede nyo rin naman malaman yan from the change in free energy formula that we had before, yung minus S dt plus VdP, right? So, dyan naman galing yan. At since constant temperature yung pinag-uusapan natin dito, so mawawala itong term na ito. And you will get dg equals vdp. Okay? So, there. Parehas lang naman yung lalabas. Now, if you have a case for gases, okay, gases, and here we're going to assume perfect gases, they obey the ideal gas equation. Yung equation na ito, okay, will be or can be expressed as dg equals nRT over P dP. Okay? Now, we will integrate this equation, initial to final conditions, so that you will be able to obtain an equation to calculate the change in free energy equals nRT ln of P2 over P1. So, yan ngayon yung final equation natin or final working equation, you would say, to calculate the change in Gibbs free energy for ideal gases and how it depends on pressure at constant temperature. Tandaan nyo lang yung title natin, we are at pressure dependence when T is constant. Okay, so that's for gases. But how about for condensed state? Pag sinabi natin condensed state, that includes liquids and solids, no? So, condensed state. Ang condensed state natin, solids and liquids, volume is essentially constant. Okay? Volume is constant. If that's the case, yung ating equation kanina, this one, dg equals vdp, let me write that again. Since constant naman si volume, we can integrate it right away. So that for liquids and solids, delta G will be equal to V delta P. So yan yung gagamitin mong working equation kapag condensed state ang meron. Ngayon naman, balik na rin natin yung sitwasyon. So paano kapag yung Gibbs free energy will depend on temperature naman this time when pressure is constant. So let's find some mathematical expressions for that. So balikan lang natin yung dalawang relations kanina, these two. Okay, so kanina nagamit na natin tong second, this one, right? Now, ang pinag-uusapan natin ngayon is temperature dependence of Gibbs free energy. So therefore, we are going to utilize this one. Okay? So let me rewrite that. So that's partial derivative of G with respect to T kasi ka temperature dependence at constant pressure, and that's equal to minus S. Yun lang. Yan yung paraan para makita natin yung temperature dependence. Ang problema, entropy is not too much of a measurable quantity, right? So, hanap pa tayo ng ibang formula, equation, relation to show how Gibbs free energy depends on temperature at constant pressure. So, what will I do is, ang gagawin natin ay i-differentiate natin instead yung G over T ratio with respect to T. Okay? At constant pressure. So, what will happen if we will do this? So, derivative ng G over T. So, we have a ratio, right? So, if you recall your differential calculus, so, ang mangyayari dyan is, yung denominator, i-square lang natin, right? Tapos, sa numerator naman, okay, take the denominator and differentiate the numerator. So, T times derivative of the numerator g with respect to t tayo at constant p. Minus, take the numerator and differentiate the denominator. So the derivative of t is 1. Now, ang mangyayari dyan is you have t, okay? Now, the partial derivative of g with respect to t at constant p, yan yung kanina na s or minus s, right? So, t times minus s minus g over t squared. Okay, so you have, pwede mo siyang i-express as negative ts plus g over t squared. But remember the definition that g is equal to h minus ts, right? So if that's the case, yung minus ts natin, mapapalitan siya ng g minus h. Tapos may minus g ka pa dito over t squared. So, ang pinaka-final form ng relation natin will therefore be minus h over t squared. So, yan yung change in g over t with respect to t at constant p. Okay, and this equation is quite useful as you will see in the next video lecture.